All right, got one more example here. Oops, sorry. And it's another rational function with a end behavior asymptote or a slant asymptote. And we know this by looking at it since our numerator degree is greater than the denominator. So I'll get a marker I can use for pointing here. Use a color that will be noticeable. So our numerator degree x cubed greater than our x squared. And if we put in really big numbers, right, it would just keep getting larger and larger and larger. So our end behavior would go to infinity. And that's how we know it's a slant. So I'm actually going to start right off with finding our slant asymptote. So using division. So you guys should try that out. I'm going to just really quickly scroll through my writing and go through. So I've got my slant asymptote. Turned out to be y equals 1/2 x. And again, pause, take your time, find it on your own, make sure it matches up. And I'm going to write this now in like this new form. Whoop, that was way too much. With 1/2 x plus that remainder over my original denominator. So again, the only difference between how we've been graphing these so far is now finding the slant. For the rest of this, I'm going to do everything else the same way. So I'm going to go back and factor this function and find the domain, vertical asymptote, intercepts, and determine if it crosses our slant asymptote. So this would be a good time for you guys to pause the video and try all that out. Throw stuff on your graph, see if it matches up. Otherwise, I'll pretty quickly talk through here and pause when you need. Right? So my domain, just that denominator, positive, negative 2, goes right along with my vertical asymptotes at positive, negative 2. And our intercept looks like only one x-intercept in our numerator, x cubed. And I also like to note that that's multiplicity 3. So now I'm going to cross through the x-axis there. So let's put all that on the graph so far. Got my point. And we can even see right now my intercept is on our slant asymptote. So it looks like it's definitely going to cross, but we should set our slant equal to, and I like to use, again, this kind of other form we have here, that asymptote form that we look at. So we can use that one. Again, I'm jumping ahead way too quick to simplify. So I wrote it out. This is always going to happen for us, right? Our slant cancels with that slant that we found. I would multiply that 2x squared to 0, and I'll get 0 equals my remainder. So that's kind of our shortcut. If you take 0, set it equal to the remainder after division, we could figure out if it crosses the slant. And here, we already knew it crossed at 0, but this just tells us we don't have any more spots that it crosses. All right, so we'll talk about some strategies on graphing these quick ways. And my hint to you guys is actually to go back at this form and check out our remainder here. Notice that it's positive. So if I put in really big numbers, my graph's going to go towards 1/2 x, but it's just going to be a little bit greater, right, than that, because this is a positive fraction at the end. So anything that's really big is just going to be above that line. So that's one way to think about it. So we would know that this last piece of our function over here would be in this top part because that fraction's positive. But if that's not making sense to you, I think something really helpful, at least for this one, is just to check one point. So I'll put f of 1 in here I like to do the factored form, and that turns out to be negative 1/6. So I'm going to put that point on my graph, and that means my graph's going to go down in this little area. And since we crossed through that x-intercept instead of bounce, it's going to go up over here. I can use multiplicity rules. And I got a lot going on in here, but I'll try to highlight, right? So down here, both of my asymptotes are multiplicity 1, so that means I'm going to cross over that asymptote, and my graph's all filled in. But remember, we'll have scientific calculators, so definitely check any points that you need to, and we'll be all set.